in a moment. Okay, so we're going to go back to the PowerPoint. And now we're going to talk to innate immunity. So that's your body's ability to produce antibodies and to make the response. You can get, like the Moderna and Pfizer, they're going to expose you to the antigen by giving you the messenger RNA, which gets into your cells by being encapsulated in a little fatty globule, and that's how it gets into your cells, and it's going to produce the antigen, the spike protein, and or you can get uh, antibodies that are made, that's passive immunity, that are made against uh, diseases by growing on a rabbit or whatever, like the monoclonal antibodies, that treatment that Trump got very because he had it available to him. So when you get antibodies produced outside your body and injected into you, that's like the monoclonal antibody cocktail. So innate, genetically determined, acquired. Active immunity is when your body responds to antigens. It develops after exposure to antigens and uh, develops after the antigen. So this is the approach for you to make antibodies by responding to the taking in the messenger RNA. It gets into cells through a lipid particle, a fatty particle, so it won't be destroyed. You will take that messenger RNA, make the spike protein, and you will make antibodies and have 5 to 10 times more antibodies compared to surviving COVID. So the mother will give the baby antibodies in breast milk. That's why it's so incredibly important. And here's an induced passive immunity where you uh, produce antibodies. You get antibodies produced in the lab, and the monoclonal antibody uh, treatment is what that's about. Okay, specific immunity by B cells. It's specific to the uh, pathogen or the antigen produced. It has memory, it remembers the infection. It's versatile because your immune system has a whole genetic library of directions to make various antibodies against uh, particular pathogens, against the particular antigens. And I'm not going to worry about tolerance. Okay, so T and B cells recognize the antigen. It produces millions of antibodies in response to that antigen. Memory cells can uh, make sure that after you get it the first time, it may take a couple of weeks to develop antibodies, but it can ignore our mentioned tolerance here. It ignores your own antigens, own proteins. That doesn't always work because sometimes uh, our autoimmune system attacks us. So this immune response is to get rid of pathogens, abnormal cells, and foreign molecules. It's based on lymphocytes uh, recognizing a specific antigen, and there's a whole recognition system. So the bacteria and their foreign proteins can be recognized by cell mediated immunity, which means phagocytes uh, activated, and T cells uh, stimulate antibody production and recognition of the foreign proteins on the virus, for instance, like COVID. So cells will attack and activate T cells, which help the production of antibodies. Antibodies are represented by a little Y. Okay, based upon your genetic complex, T cells recognize U, the major histocompatibility complex, and T cells are going to help recognize the foreign proteins. So T cells are cytotoxic. They attack bacteria and viruses. Memory T cells set up a memory so that you can very quickly produce antibodies. The suppressor T cells that are there to make sure that your body doesn't go overboard. And we heard about the cytokine storm that COVID produces, and a cytokine storm can cause problems by destroying cells and generally confusing the body as to what's happening. So an infected cell is red or classified, and you get cytotoxic T cells that are going to attack cells, and then you're going to have memory T cells that are going to be involved in the production of antibodies and remembering the pathogen, so that when you get a secondary infection, you're going to be much better prepared. Okay, cell-mediated immunity depends upon cytotoxic T cells, foreign, abnormal, and infected cells, and T cell activation, where the antigen is presented. In other words, the immune system recognizes that antigen, antibody generator, and that antigen is going to stimulate the production of antibodies. So B cells are sensitized. There's a whole recognition of the antigen, and that's going to help the B cells produce plasma cells, which produce antibodies, a particular antibody meant to attack, in COVID, for instance, to attack the spike protein found on the surface of the virus. Memory cells are produced, and once you have memory cells, you're going to have these plasma cells ready to go. So antigens, for instance, on the these antigens are presented and sensitized, and the bottom line, what I want you to know, as these plasma cells make an antibody that is ready to attack the particular antigen. To repeat, that's why the Moderna and the Pfizer vaccine give you the messenger RNA to get into your cells through a lipid capsule. Once that messenger RNA gets into your cells, the cells make the spike protein, and the immune system is able to produce plasma cells that make that antibody that's particularly generated against that spike protein. Okay, all we want to know is that the antibody has particular heavy chains and light chains and so on. And these antibodies are going to bind to the spike protein on the virus and help destroy the virus. So there's different types of antibodies produced. Just know in general that there's G, M, A, E, and D. Okay, let's stop there. And this whole We'll come back to this slide in a moment. So if we go to minimize right here and stop recording,